Every time you browse the internet, send an email, or stream a video, or even make a simple online search, you're using a technology that was first developed in 1970 for military communications. The technology is TCP/IP model, the foundation of modern internet. So now let's explore what is TCP/IP model and why it is important. TCP/IP model, also known as DARPA model or DoD model, was created by US Department of Defense long before the OSI Reference Model existed. While the OSI model has 7 layers, TCP keeps things simple with just 4 layers. So as you can see here, we have 4 different layers: application, transport, internet, link layer. So if you want to compare OSI model with the TCP, you can see here we have 7 different layers. So whatever happens within these 3 layers, like in the previous video as we have seen, these are different operations which have been performed in the starting 3 layers. So whatever it is done in this particular application layer in TCP/IP model, right? And next, the transport layer, it is as is. So right now, whatever operations that we have discussed previously, like what happens in the transport layer, everything happens same in the TCP and IP model. And next comes network layer. So network layer has been changed to internet. And coming to data link layer and physical layer, these two have been assigned as link layer. So this is how you can compare it. I'll just, in the TCP IP model, this is also known as DARPA model, or let's say DoD model. Even though TCP IP model is simpler, it forms the backbone of all modern networks because it was built from real working protocols, not just theoretical concepts. And it's the same thing, you can see like in the application layer, it's message, and transport it's TCP, and UDP, in internet it's packet, and in the link it's frames and bits. Starting at the top, we have application layer, also called as process layer. This is where the user interacts with the network. If you're using a browser, sending an email, or transferring a file, all these actions rely on application layer protocols like HTTP and SMTP. This layer essentially acts as interface between the user and the network services. Or maybe let's consider the same scenario like what we previously considered. An email which is sent by user 1 to user 2, and let's say they have multiple information within that particular email. So they are so the user 1 is sending to user 2. So how does user 1 send to user 2? This is where the application uses a protocol like SMTP to prepare your email, making sure the message is readable and formatted correctly. So this is like writing a letter before sending it. Here we are using email, and which will be using as SMTP protocol. I'll add here the application layer has layer. Next layer is transport layer, sometimes referred to as host-to-host layer. So this layer ensures reliable communication between the devices. So two major protocols work here. TCP, which is transmission control protocol, which is connection oriented and reliable. And next we have UDP, which is user datagram protocol, faster but connectionless. So these protocols handle flow information, error connection, and data segmentation, ensuring smooth and efficient communication. So as you can remember previously, layer, it is segregated into different parts. Part 1, part 2. So similarly, if we consider email, it should be ordered, right? The user too should receive the same message. So that is the reason it has the sequencing. This is where the transport layer will be useful, right? So going back to the example, here TCP breaks your email into smaller pieces called as segments, numbers them, and ensures they are delivered safely. So let's consider we'll consider just a starting stage. So here the good day, it will be segregated into different parts, like let's say part 1 is equal to G. So it is changed into these different parts. If there is a situation where let's say for example part 2 has not reached user 2, the TCP will ask to resend that particular segment so that the user can receive email in a correct format. Next we have internet layer, also known as Internetworking Layer. This is where IP or internet protocols reside. The main goal of this layer is routing and addressing. It decides the best path for data to travel across multiple networks, making sure information reaches the correct destination, even if the destination is on the other side of the world. So here, the IP address are added to each piece. So routers on the internet know where to send them. So this is like writing the to and from addresses on the envelopes and choosing the best route for them to travel across towns and cities. So this is where you see all the IP protocols come and addressing. This is what happens at the internet layer. And next we have link layer, which is also called as network interface or network access layer. This layer deals directly with the physical network hardware, whether your data travels through the Ethernet cable, fiber optics cable, or Wi-Fi. This layer handles how the data is actually placed on the network medium. Protocols like Ethernet and Wi-Fi operate in this particular layer. Going back to the example, now the email signals reach this link layer. So at this stage, the data is converted into bits, which is zeros and ones, and sent over the cable or wireless signals. So this is like putting the envelope onto a truck to deliver them to the post office. So this is where you'll be having zeros and ones, and it will go through the internet. And so just so give you a just like what we have done till now. So we have application layer, which is also known as process layer. So this is where the email is sent. This is where you interact with the application. So here you will be sending, let's say, here, let's say you just send hello. It's not just hello. So there are multiple processes which are running behind it, right? So when we have compared with OSI model, there are three layers, right? Application, present, and session layer. So this is what happens in these three layers, right? Formatting, like when you send hi, it's like there will be a formatting and encryption, and then you will be having a session ID. So everything happens internally, in this TCP model. And then we have transport layer. So here your data is converted into different parts, like P1 equal to H and P2 equal to E. So basically it will segregate into different segments, and know why it is used, why we are using this different segmentation concept, because whenever it goes to the user side, they should receive a correct order, right? So send an email, the subject should be at the top, and then you have the body. It should not be in the reverse order, right? The body should be in the top and the subject should be in the down. So it will have the sequencing, and based on that sequencing, the receiver will be getting all this information. So that is what happens in the layer. And networking layer, all this about IP protocols, because if you want to reach to user 2, you should know the IP, right? What's the public IP of that user. So using the concept of IP protocols, routing and addressing, it can find your friend's IP and then send this email. There are a lot of concepts behind this which are running, like DNS and all those things, which we'll be discussing in further videos. So this is what happens at the internetworking layer. Then we have a link layer, so where you have frames and bits. So here, once you get zeros and ones, it will send to internet, and like how we have discussed previously, in the user 2 side, so layer by layer, it will be trying to remove all these encapsulated message and try to save your email and send it to the user 2. So that is what on a high level what happens. One important thing to remember is that TCP IP model was derived from the actual TCP IP protocol suite, which includes hundreds of protocols that all work together to make communication possible. Because of its open standard and platform independent design, TCP IP is used in almost every operating system today. However, there is a catch. TCP IP was designed mainly for interoperability and ease of communication, not for the security. As a result, it also consumes more system resources and is more vulnerable to attacks if not properly secured. So common threats include buffer overflow attacks, DOS attacks, fragmentation attacks, and many more, like man in the middle attacks, and even passive attacks like packet sniffing, where attackers silently capture data. To protect against these, organizations and individuals use layered security approach. This includes firewalls, network filtering to block malicious traffic, and encryption like HTTPS, TLS, and VPNs to secure the data in transit, and strong authentication to ensure only authorized users access the network. Keeping systems and softwares up to date reduces vulnerability caused by coding errors, while monitoring tools and intrusion detection system help identify suspicious activities quickly. Following safe network practices like avoiding unsecure networks and using secure protocols reduces the risks of interception, or hijacking. So I hope you understood the concept of today's video. If you have liked the video, please click the like button below and subscribe for more such videos. And also feel free to share your thoughts in the comment section below. Thank you.